should we do to ensure good results? Here's some examples of some information out there that we tend to use, some of which more than others. The DOE reference building model in the EER Building Energy Data Book, the Department of Energy funded a program that basically looked at Energy Plus to basically model different buildings in different climate zones, so that then you could benchmark your benchmark your results against to see if you're in alignment with what's your kilowatt hours per square foot of plug load, what's your lighting, what's your cooling, is it all relative, or your plug load's way too high, or your cooling is too substantial. It's a good way of referencing and doing quality control when you're doing the analysis. The Building Energy Data Book is real nice because that's the energy efficiency renewable energy program. They created a data book that just gives statistics on all kinds of buildings. So when you're like, where are we? Are we in line with where we should be for our type of building and our climate? There's a lot of information in that book that'll give you end-use breakdown. Oh, hot water in a, Zach, referencing your project, hot water in a luxury hotel should be this versus Hilton or something, and using that to kind of inform where we think we should be, and using that at design so that our model has more meaningful results. CBEX, this is what Energy Star is based on. It's the Commercial Building Energy Consumption Survey. Energy Star, everybody's familiar with that, is all based on that. Now, the CBEX data is dated to 2003. So everybody was up in arms when the 2007 data got rejected by the entity that was reviewing this because it wasn't good enough. That doesn't mean this is invalid, because the CBEX basically has hundreds of years of data up to 2003. So how much has changed between 03 and 08, right? So this is a great tool that we use to make sure that we're in line in terms of energy use intensity, kVt per square foot, that kind of thing. ASRAE 90.1 Appendix G User's Manual. Pull this thing up. This is our world, this document right here. Our world also lies in about the last 8 pages of this document. So when you're trying to do a whole building energy model based on this information, the Appendix G User's Manual is good in some cases, poor in others. What it does is it says, okay, you need this kind of operation. You can go to the User's Manual, and we'll tell you exactly how you need to set it up in the interpretation of the folks that created this standard. So that's a very good manual. A lot of people aren't aware of it or don't use it. Most of the stuff in ASRAE is prescriptive. There's a lot of prescriptive requirements, and a lot of the codes that are coming out are adopting ASRAE. So while this is a standard and not a code, some of the codes that are coming out are just absorbing this. We're starting to see now ComCheck. We've done a lot of stuff in Montgomery County, and now the code officials are actually asking for this stuff. You've always had to provide it, but they never really reviewed it. And now we're like, where's your ComCheck for your lighting? Where's your contract for your envelope? So there's a whole paradigm shift in terms of just setting the right insulation level in a multifamily wall that never existed before. So code officials, things are going in that direction, and as long as we're responsive to that and flexible to those changes, we should be in good shape. This is one, ironically, we don't use, but it's good if you're just trying to get a framework for lead models. Most of this stuff we've been doing for years, but there's been a lot of questions. ASRAE is an interpretation. Energy model is a professional interpretation. And what LEED and ASRAE are trying to do is taking less interpretation out of it, and that's why this document's getting thicker. They've got this guide that basically shows you what do they mean when they want you to break this out or that out. What do they mean when they want you to itemize this model? Why are they asking me a question about fan power, which you're going to get, or brake horsepower, or this? The advanced energy modeling for LEED is kind of good if you're kind of just getting into it, but it's not as advanced as I think it should be. Last thing, do not blindly trust the output. It does take a trained eye to look at this. This standard is constantly changing. I mean, this is the basis for everything. For those that don't know, ASRAE is a theoretical black box building in this little manual. Essentially, if you built your building exactly to the energy standard, your result would be this. So in terms of modeling, We could go into a million different things of interpreting everything in this document, but I think for the purposes of this presentation, I wanted to hit on 5 things. That if you're looking at a baseline or your consumption of a model and you want to make sure your baseline is correct, because those of you that have gone through reviews, how many questions are relative to ASRAE baseline? Most of them. Wrong baseline, your interpretation's wrong, you've got gas when you shouldn't. It could be a nightmare. So I think in order to make that process a little smoother, I've got it in here in no particular order. One is standard influencing design decisions, EA credit 1 points. A lot of on lead is not necessarily what you do, it's what you're being compared to. Karen, we talk about this a lot in terms of large schools. Montgomery County does a lot of great work in geothermals and things, and we'll see drastically different performances depending on the size, because if you're doing a smaller school, you're compared to a lesser performing system versus a big school where you're compared to a really good chiller, so the performance is different. So when we have expectations on projects going in that we're going to see a certain performance, we need to make sure that we're making design decisions relative to the standard. I've got 2 great examples of this. I've actually got many more examples of this, how, believe it or not, ASRAE is changing the way mechanical engineers sets up their system.